Hey there, back at you with another video. This one's going to close the loop on that 4L60E where the forward drum was stuck inside the case. So after a lot of wiggling and jiggling and shaking it up and down, all around, left and right, backwards and forwards, I finally got it out. It was literally about 2 seconds away from being tossed into the scrap bin for disposal. So when I pulled it out, I'll be honest, I was kind of surprised in the lack of carnage. I was expecting completely toasted and burnt 3/4 pack, melted and welded, sun gear, planets, ring gear, all destroyed, but they actually don't look half bad. My opinion on the drum itself still remains, no matter what I find in it. I'm not going to reuse it. I mean, even if it checks out in terms of the leak test that I always do with these, even if there's no obvious signs of physical damage visually, I don't know if there's maybe some subtle micro fracture somewhere, especially on the crown where you saw in the last video the bearing and the little selective spacer there all beat up, scored, and reverse input drum, the snap ring and return spring was sitting on the input shaft and whatnot. So regardless, this drum saw a lot of abuse, and I would just simply not want to reuse it, not take a chance with it failing catastrophically shortly after the thing goes back into the vehicle. So we're going to continue with the teardown on this one. I'll start with a drum pressure test like I usually do, and then we'll proceed tearing it down, looking at all the different clutch packs and the Sprag and the gear and whatnot, and seeing what we can see. It's always interesting when you get one of these in and everything's kind of foobarred, or at least it appears to be foobarred. So, all right, enough of me babbling. Let's go ahead and get into it. All right, so if you haven't seen me do this in any of my other videos before, what we're going to be doing is a drum pressure test. What we want to see is if there's any leakage here where the shaft is pressed into the drum, and how we do that is we inject air into each of the feed ports, and then we look for bubbles inside the fluid. So let me actually raise this up a little bit, and then we'll get started. Alright, so here at the bottom we have our 2-3 feed hole. In the middle we have our forward clutch feed hole, and up here we have our coast clutch feed. So what I'm going to show you applies to both 4L60Es and 700R4s, and it's a quick, simple test to just show you what kind of state the drum is in and if it can be reused. So any bubbles here in the fluid will tell me that this drum's no good. Alright, so let's go ahead and perform the test. So we'll check 2-3 feed. Alright, you see that bubble there? This is a perfect example of what is very common in these transmissions, and that is a leakage here at the 2-3 feed. I mean, that's actually pretty bad. Most of them, it's going to be some subtle bubbles forming, kind of down at the very base of the shaft where it meets the drum. But I mean, this is, kind of, screaming and shouting to us, "Hey, I'm shot. I'm done. Throw me away." All right. So let's take a. So let's do the forward. Okay, nothing there on the forward. Now when you do the coast clutch, you got to plug the forward with your thumb or finger. Okay, we see a lot of bubbles. Yeah, it's like a bubble bath down there. Alright, we know that this drum is no good. I mean, we knew that going into it, but this is good, visual evidence showing that how you can test these drums and confirm or deny that they're going to hold pressure or not when you go and rebuild the unit. So we're going to stick this into the scrap bin, but let's go ahead and disassemble it and see what everything looks like inside. All right, so let's dig in. Here we see Raybestos. This might be Z-Pack or something similar. I've used Z-Pack in the past. No real issues with it. I've always was a little bit concerned about how thin all of the one-sided frictions and steels were. You know, I was always paranoid that, like, as soon as they saw just a little bit of heat, they'd, you know, fold up like envelopes. All right, so here's the pack. So these are all what we call one-sided discs. You got your backing plate, and then you have friction material on one side, or at least you used to, and then you have the steel on the other. Okay, so it's not like a traditional friction end or traditional steel clutch pack. This is why I don't use Z-Pack very much. I mean, this transmission was, you know, horribly abused. This probably would have happened, you know, no matter what was in here. But these tend to cone very easily. So you see how conical that is. Okay, these things are absolutely 100% smoked. I mean, you can tell. I mean, they are very, very rounded. So a few of these were likely tack welded to the outside of the ring gear there, the hub, and that's why it was so difficult for me to get this drum out yesterday when I was going through it. So needless to say, all that stuff over there is worthless scrap metal. Now, I was expecting this to be all melted, because from what I've seen, at least the worst of them, examples where something is welded to something else and the drum won't come out, this is all tore up and, you know, partially or entirely welded to the pinions in the planet, and then the planetary carrier is welded to the interior of the ring gear, and you know, you'll never be able to get that out unless you cut the case open and, you know, do hard extraction or something. So let's see what we got. So I would expect some of these frictions to be partially or totally burnt. Got two coast clutch frictions and steels. We'll look at them in a second. I get the rest of the forward clutch pack here. Is our wave plate, and then I actually don't see too much stress or wear on the forward clutch, which is not unusual. The forward clutch is what we call a non-working clutch. Once it's on, it never comes off until you put the vehicle in either park, reverse, or neutral. So if you're in drive 3, manual 2, or manual low, these clutches will be on and they will stay on. Alright, so the apply plate looks okay. And then I believe these are probably choline steels. And you see a little bit of slippage on these. But these I think were either lindered or choline, which is the right thing to do. I always use, or I shouldn't say I always, but like I very often will use either lindered or choline steels on high performance builds. Okay, so no obvious damage to the the cushion plate. I mean, that can be reused. No obvious damage to the apply plate. Check it on a perfectly flat surface to make sure that it is truly flat, but assuming it is, it should be fine to reuse. So again, some cholines here. We do see a little bit of slippage, a little bit of signs where there was some heat buildup, and I mean, you saw the drum, it was leaking like a sieve at the coast clutch feed port. It was not leaking at the forward, so it makes sense that the forward clutch was okay for the most part. So the apply plate looks fine. And as my customer had said, he was doing a lot of shifting manually with this thing just to try and, keep it on the road, keep going and whatever. So, he was using the Coast Clutch pack a lot more than, you typically would. Okay, so here is the input Sprag assembly. You have clockwise rotation on the larger outer Sprag race, and then it locks counterclockwise, and this one is functioning. He didn't say he was neutral in drive, so if you're neutral in drive, but you have forward movement in manual low or manual 2, then that's going to be the input Sprag assembly. Sprag rolled over, failed, and as a result, when you throw it in drive, you're not going to have any forward movement. Okay, every once in a while you'll see these splines stripped off the Coast Clutch hub. So you see some wear here. There's a lot of force here. A lot of probably a combination of force and particulate matter scoring this up. I would not reuse this again. It's worn down pretty good, as you can see. I wouldn't bother. I mean, those things are rare. This is interesting, and I say that because it looks to me like this is the original Sprag clutch that came out of this, or that, I should say, that was installed into this thing from the factory. I mean, yeah, it's coming out now, but this should have been replaced when the transmission was, getting built up for that 1,000 horsepower equipped vehicle. Okay, you see, look at the stress that this thing endured. Okay, that thing is coned out, warped. Okay, this one is a little bit better. I mean, it's not totally messed up like the other one is, but I mean, you can tell, look at the Sprag assembly itself. I'm not going to tell you that you can easily be able to distinguish a worn Sprag clutch like this, dog bone style clutch from a brand new one, but there are some telltale signs. You can look at the individual rollers, if we were to clean this up, but I mean, I can tell just by handling it that it's worn out. I mean, I couldn't roll it over by hand myself, obviously, but if by whatever reason the 3/4 pack didn't just totally go out on this thing, I would imagine this Sprag would have rolled over within the next 1,000 miles, maybe 2,000 miles tops, and that's with normal driving. So the inside looks a bit worn as well. I mean, you see how mirrory smooth and shiny that is? I mean, there's a little bit of cross-hatching visible. I'm going to make sure that that's in focus. But when you see a race that looks like this, where you can almost see yourself in the reflection, you can kind of do your hair and check yourself or whatever, almost as well as you could using a regular mirror, then you know that you probably need to replace that race. You could try to use sandpaper to reintroduce crosshatch, but again, in my opinion, anytime you see a race like that, I would just get another one. They're not expensive. Now, the inner race is the exact opposite. You want to see a perfect mirrory smooth finish on the inner race. You don't want to see scoring. You don't want to see any bluing or heat marks, anything that would lead you to believe that it's damaged. So this particular gear here and the race are in good shape. Okay, I was expecting this thing to be completely welded over, melted, burnt to a crisp, but that's not the case. These bushings, I can't really tell if they were replaced or not, but they look like factory bushings to me. Okay, they don't look new. I know I didn't show the pump, but the pump had replacement bushings, and those bushings were, they were shiny. I mean, you could tell that they were not the original bushings. So this is actually okay. Stuff that I'm putting over here is not. Okay, this bearing endured a lot of stress. It feels okay, but again, it's in light of everything else that you know about what happened with this thing, that's not something you would reuse. The snap ring itself, and it's a kind of a judgment call, but I'm inclined to stick it over there in the scrap bin. The snap ring for the forward clutch and the 3/4 pack is fine. I mean, those things are nearly indestructible. Okay, so an HD2 shift kit was installed into this thing, so the forward return spring and the 3/4 return spring should both have the high rate return spring kit installed that comes with the Transgo HD2. As mentioned in my other videos, you can purchase that kit separately, and I always do. It's a great kit for anything high performance, or even if you just want to crispen up your 3/2 downshift and mitigate centrifugal apply, that's the kit to go and install. And that's the kit to go with to do that. So let me go ahead and take the snap ring out, and then we'll come back and we'll get all the rest of the contents and take a look at them and see if there's anything interesting to note and observe. Alright, so snap ring's free. So we got what appears to be high rate return springs. And I say that because when I push this on the bench like this and I push down on it like that, all my weight, these springs feel like they're, stiffer than the factory springs. All right, now when you get this stuff out, all you got to do is wrap it on the bench like that, and it'll all come out. All right, now this is interesting. I'm not sure if these are the high rate return springs or not. Now the kit comes with a few different sets of 3/4 springs, but it explicitly tells you that you want to basically pry these little engagement tabs completely rearward so that they do not engage the corresponding hook, engagement points, because the springs are simply too stiff, and you'll never ever get them, safely engaged in the way that you see on this one. So this tells me that these springs may not actually be from the kit. And let me revisit this. I mean, yeah, I said I could tell, but all right, I'm able to do this, and these are factory springs. So I take back what I said just a few seconds ago about them being the Transgo stiff springs, because they look identical. Visually, they're indistinguishable, between the Transgo and the factory springs for the forward. But this is clearly not Transgo stiff springs. I mean, there's no way I'd be able to do this. So we'll have to install a spring kit. And I'm not, for the life of me, I'm not sure why the previous builder did not install them. I mean, they come in the kit, and every other part that comes in Transgo's HD2 shift kit was installed in this transmission. I even took valve body apart, and it had all of the shift kit components that come for the valve body in that valve body. So it's a mystery to me why the previous builder did not install the high rate return springs, especially if the transmission was going to see 1,000 horsepower. I guess he figured stock springs are actually the way to go. I don't know. But again, like in the other video, it was mentioned that this transmission was supposedly built by a well-known, nationally renowned builder or manufacturer, remanufacturer. There's no way that that's the case. This was built by somebody, again in the back alley or in some maybe some flat rate shop. Who knows? Because there's a lot of things that I'm seeing that should have been done that were not. The bushings in the gear there were not replaced. They look like the original factory bushings. The Z-Pack was installed, but again, I generally don't use it. This drum more than likely was not tested by whoever built this thing last. It is leaking like a sieve. Maybe they did, I don't know, but my guess is they didn't. It's not super common knowledge, even amongst transmission builders, that this should be tested in a way that I demonstrated a little bit while ago. Alright, even if this drum was not leaking, when you see carnage like what we saw with this transmission, evidence of a lot of parts just simply being almost forced or ground together, and again, I think I mentioned this somewhere in the other video, this had almost no end play, basically no felt end play, so I'm thinking that it may have gone together with less than 10 thousandths worth. And what you have to be concerned about is micro fractures in here. Okay, so in here that you can't see. So if you were to put this back in, and this actually happened to me once, and that's how I know, the drum will eventually crack, and the 3/4 pack will burn up, or just simply you'll go neutral because all the applied fluid's hemorrhaging into the case. So on this side, you'll see the micro fractures start to appear here on the base of the pocket. This is not the Transgo check ball. I think I said it was when we were just looking at it in the previous video. I haven't had a chance to really scrutinize it, but this is the factory bleeder ball that goes into every single one of these drums. So the Transgo high rate return spring kit comes with an updated, modified orifice that is, there's no check ball or bleeder ball or anything. It's just an orifice in that plug, and you just put it in with a drift punch. You take this out and you put the Transgo one in. All right. Only other areas that you would scrutinize are the lugs here, and you want to make sure that they're not gouged out. This one actually doesn't look too bad. I've seen them where they're like literally just big chunks carved out in the area where the portions of the reverse input clutches are splined onto. And when you see that, obviously you want to replace the drum, because otherwise those clutch discs will get caught up and you'll start to slip in reverse, and eventually you'll burn the reverse clutch up because they're getting caught on the little divots carved out in the lugs here. Alright, gonna go reposition the camera, and we'll turn our attention to the rest of the case and see what we can find in there, see if there's any damage or if things are actually okay. Okay, here's the planet, ring gear and reaction shaft. So, looks like we have a conventional sun shell, which again, for 1,000 horsepower is a no-no. You need a rollarized sun shell here. And you should have installed a reaction shaft that is also capable of taking a roller, or excuse me, a Torrington bearing. So we got SAP here on the cover, or the cover. You got SAP here on the bottom of the shell. believe they're an aftermarket company. This is an upgraded shell. I mean, it's beefier than standard factory level replacement sun shells that they sell over the counter in the aftermarket. All right, so here's the bearing for the Planet. Journal looks okay. Visually, the pinion gears look okay. Captured bearing actually looks either new, or maybe this was rebuilt at some point, this Planet. You wiggle all of them from side to side while you're inspecting the teeth. And then you kind of wiggle them vertically. And what I'm seeing here, these have an appropriate amount of play. What I was expecting to see is all this welded together with the front sun gear, and at minimum seeing heavy bluing and or signs of heat soaking here on the top portion of the pinion, where the pinions are pressed in, and not as much toward the bottom, because this is the side that faces away from the source of the heat. But I usually see all this blued, burnt. Sometimes these are physically loose inside the housing, but this one looks okay. You scrutinize the splines; they look perfectly fine. So, ring gear, ditto, looks perfectly fine. This is a reaction shaft that is standard for anything 2002 and back. In 2003 is when they went to a rollerized reaction shaft. They eliminated this Babbitt style thrust washer and replaced it with a bearing. So, for just a basic performance upgrade in the middle of the case, you can install an 03 and up reaction shaft and that bearing, and that'll give you a little bit of heat dissipation there. And then if you're going high performance, it's recommended that instead of a standard sun shell like this, you install something that's rollerized, so where the thrust surface between the center support and the sun shell is rollerized as opposed to just this black thrust washer. Okay, now this thrust washer is used in conjunction with this shell. So this is not a factory. This is not a factory thrust washer there between the sun shell and the center support, but it's still a thrust washer. So, in my opinion, they should have put a bearing, or a sun shell that takes a bearing. Okay, here's the sun gear. You'll notice that a Sonex oversized bushing was installed. At least I think this is a Sonex oversized bushing. This is the right call to install. It looks like it's protruding a little bit, so even then it may be walking. There was a lot of, stresses put on that bushing. So imagine if it was just a factory bushing, it probably would have walked out already. All right, let's take a quick look at all the teeth and the splines. Again, they look perfectly fine. One thing you want to do with these in high performance is cut very shallow slits here at the 3, 6, 9, and 12 position, and that will allow lubrication to flow to the bearing and the Planet. A little bit more lubrication than it otherwise would see, and that's especially important at high RPM. Alright, let me try to work around this tripod. Get the snap ring for the center support out of the way, and then we can pull the rest of the contents out of the case. And the only thing that'll be left is the low reverse apply piston and return spring and such, which I'm not going to bother with. I mean, maybe no different than any other one you've seen. Hey, sometimes you have to get aggressive with it. just yank on it from the back and, you know, the output shaft, I mean, and pull it out. Every once in a while, at this area, you know, here, where the ring gear spline's on, you want to scrutinize these splines real carefully, because a lot of times they're chipped, and you'll see that, and it's not real obvious, especially if you know, there's fluid just kind of impregnating the spaces between the splines. So you just want to make sure that you're not dealing with strip splines or chip splines or whatever. You can check the front splines. I don't see these bad too often. Just pay close attention to the splines forward of the snap ring groove. And of course the journal. This journal actually looks perfectly fine. No signs of heat damage or, you know, warping or scoring or anything like that. So this output shaft looks perfectly reusable to me. You know, you can check it, you know, just kind of eyeball it. It's going to be hard to do with the camera, but make sure that it's not bent, okay? That's pretty rare. I mean, it takes an ungodly amount of force and stress to bend one of these shafts, but, you know, I'm sure somebody somewhere has seen it. I never have, and I've done over 1,000 of these things, 4L60Es and 700 R4s in my lifetime, and I've never seen it. Alright, so we got our bearing, and then, like I said, we got the low reverse apply pistons set up in there, and in the case bushing. So case bushing looks like it's where it should be, where it's supposed to be. Alright. Center support and low reverse. So these frictions, by the way, I believe are the Alto Reds. You know, if you read up on you know, the different frictions available for transmissions online, you see a lot of mixed opinions on Alto Red clutches. You know, when I say that, I mean like amongst you know, well-known reputable builders. Some like them, have no issue with them, and use them. Others can't stand them and, you know, just will never use them. They prefer factory frictions. For my part, I don't use them very often. I actually prefer the BorgWarner or Alto High Energies, or Raybestos High Energies, or ZPGs. And the reason for that is I think they're a little bit more suitable for the street. And the reason I say that is because they tend to hold a little bit more fluid than do the Alto Reds or the Raybestos Blues. Those clutches are designed to be like no compromise, you know, absolute beasts when it comes to just holding and dealing with like ungodly amount of torque, you know, input torque and all the associated stresses, but they don't hold as much fluid. So when you're racing, you're really not, I know this is going to sound odd, but you're really not putting a lot of stress on, you know, not the same kind of stress that you would put on a daily driven car when you're racing, assuming all you're doing is racing, because the clutches will, you know, they'll be applied, they'll hold for, I don't know, 10 to 13 seconds or whatever, and then that's it. And then, you know, they'll be at rest until, you know, you make another pass. But for a daily driven or a street strip vehicle that sees all the stresses of, you know, stop and go daily traffic and, you know, related, you know, various conditions that one encounters on the road, you know, normal course of driving, you know, you'll have frictions that don't hold or retain fluid get hotter than ones that do. So the factory frictions, you know, they hold a fair amount more fluid than would the Alto Reds and the Raybestos Blues, but they're not going to hold as effective in a very high performance situation like racing. You know, a lot of horsepower, a lot of torque, and you know, a lot of things moving really, really fast. So that's my take, long-winded as it was. you'll have to kind of make a decision, you know, in terms of what's best for your build based on what you have going on. Okay, so again, I don't really see anything that concerns me with these, you know, with these pinions or the planetary carrier in general. I mean, they feel fine. No side play. You know, the longitudinal play is where it should be. And the captured bearing feels okay, so this plant's okay. Splines look okay. No heat damage, no bluing, no cracking anywhere on the housing. And I'm sorry if I'm drifting this in and out of the shot. I'm not really paying attention. Okay, wave plate, unremarkable. Choline steels. I can't find choline steels anywhere that actually are also tubular. In other words, where they have the cutouts, which sucks. Now, if you know of a place that sells them, you know, please post in the comments, let me know. But I really wish that we could find choline steels that also are tubular, because these are not. But these frictions look fine. I mean, this clutch pack would have worked. You know, the customer did not mention any issues with reverse, which is surprising given what we found with the reverse input drum. This bearing I would replace. It feels like it's a little flat. Ring gear. Again, unremarkable. All right, got everything out. So let's go ahead and summarize our findings so that we can close the book on this one. So the forward drum, reverse input drum, everything inside the drum, along with most of the Sprag assembly, are all wasted. They need to go to the scrap yard and be replaced. Same with the 3/4 pack. The Z pack is scarred and charred and absolutely smoked, so nothing can be reused there. As far as the forward clutch and the coast clutch, the steels are fine, the applied plates are fine, and the wave plate for forward is also fine, so they can be reused. I really didn't get too much into the pump, but nothing remarkable to report about the housings themselves. I mean, the usual wear, they'll have to be remachined and pocket cut for clearance, but there is one thing that I, upon taking it apart, thought was a little odd, and that is previous builder decided to install a 10 vein pump kit instead of a 13 vein rotor and slide. So there could be any number of reasons for that, but usually builders that will do this will say that the 10 vein rotor is physically stronger, and so they want that added strength for high RPM. Yeah, that's technically true, but you know, the marginal gain in terms of structural integrity you'll get with the 10 over the 13 doesn't justify going backwards in technology. The 13 vein rotors were specifically designed to provide a greater stability, better line rise, and delivery of fluid pressure at high RPMs, especially at wide open throttle shifts. And it's especially important for the Gen 3 small blocks. So you know, they are much more comfortable with those higher RPMs than the legacy small block Chevys and even a lot of the LT1s. The LT4 was just as comfortable revving to the moon. So, you know, but that's kind of an exception more so than the rule. I mean, how many LT4 engines were really produced? And of course, the LT5, that's a whole different animal altogether. All right, return spring assemblies. You have your 3/4 and your forward. Again, not sure why high rate return springs from the kit were not installed. The only thing I can think of was, and I was thinking about this a little bit between segments, was that whomever rebuilt this transmission was not the same person that installed the Transgo HT2 kit. Transmission was rebuilt, and then at some point after the fact, the kit was installed by either the owner or somebody else. And that also may apply to the billet servo assembly, because the 1-2 feed hole is way too big for this billet servo based on what we know about the converter stall speed being 3200. So anyway, if that is the case, then obviously, you know, the builder of the transmission itself, whoever installed the, you know, Alto reds and choline steels and did everything else, the Z-Pack and all that stuff, he had no way of knowing, obviously, what was going to happen to it after. So if that is the case, that at least makes sense. Accumulators, always replace your accumulator pistons, your 1, 2, and your 3, 4 along with your forward. And if you have plastic pistons, do not reuse them. And here, this would be on the rebuilder of the transmission as opposed to, well, I guess it would be on both rebuilder and installer of HD2. Somebody should have caught the fact that there was a plastic piston in there and replaced it with a new aluminum one. So that's what I would do if and when I go back with this. And as you can see, we have a new piston here. Forward piston housing. We'll want to check this. I didn't elaborate on it when I was doing the pressure testing of the drum, but when I was putting air into the forward feed hole, I heard, hissing, and it came from my nozzle, but I also heard hissing that I couldn't account for with just the nozzle. It sounded like it was coming from inside the drum. And whenever you encounter a situation like that, especially on overhaul, you want to, double check that the surface here for the lip seal on this piston, because they can get worn, and if you put it back in like that, you'll have premature failure of the forward clutch pack. All right, gear train, that checked out, no issues there. The only thing that's left inside the case itself is the low reverse piston return spring assembly. They're fine. We look at the low reverse frictions, the steels, the wave plate, they're fine. I mean, obviously I'm not putting them back in as far as the frictions are concerned. The steels can be reused, and obviously the wave plate. Center support's fine, no issues there. Sun shell is also good. Standard practice is to replace the sun shell on all overhauls unless you have something like this that was recently installed. It's a beefed up shell that shows no signs of wear anywhere on the splines, the neck area or the lugs. Now, with that said, you want to install a rollerized shell if you're doing anything real high performance or real heavy duty. Alright, so we'll wrap up with a quick discussion on the valve body and the spacer plate. When it comes to 4L60Es, I'm never really concerned about whether or not I can reuse the valve body. It's really only a question of if I have a worn actuator feed limit bore or a TCC valve issue, P1870, what it's going to take to fix it, and the aftermarket has plenty of solutions to solve those problems. So, as far as the spacer plate's concerned, we talked about the 1-2 feed hole in the last video being a little bit aggressive. But in light of the fact that we're now considering the possibility that the shift kit may have been installed at a separate time compared to when the transmission was rebuilt, and the billet servo, we don't know if that was installed either with the kit or when the rebuild happened, or perhaps independently of either of those two events. It kind of makes more sense when we're thinking about what we're seeing here between orifice sizing, feed hole sizing, as well as the lack of high rate return springs in the forward drum. So I'll talk about the 2-3 feed and the band release. You want to make sure that when you resize these holes, you do so that they're in phase with each other, so that the timing of the handshake between the 2-4 band and the 3-4 clutch pack isn't compromised. And so you want to make sure to avoid two potential pitfalls. A scenario where the 2-4 band releases too soon before the 3-4 pack can apply, and a scenario where the 3-4 pack is applying too soon before the band can fully release. So the former scenario is what we would call flare shift, and the latter scenario is what we would call a tie-up. So if you have the 2-3 feed, let's just say it's factory sized, and you hog this one out to 110 thousandths, 115, 120, and again, let's just say, then what's going to happen is that band is going to come off long before that 3-4 pack has had a chance to apply. And so you're going to have a temporary neutral condition. And here, when we say temporary, we're measuring that in terms of split seconds before the 3-4 pack fully compresses and you achieve mechanical third gear. Okay, so the cause of 2-3 flares, especially in newly or freshly rebuilt transmissions, is usually a miscalibration between the two hole sizes here for the 2-3 feed and band release. Now, the opposite problem, if you have a band release that's too slow, so maybe you hog this out to 125 thousandths and you didn't touch that at all, then you might have a 3/4 pack apply before that band has had a chance to fully release from the reverse input drum. So there you'd have a tie-up. And again, we're talking split seconds, but it's unmistakable to the point of view of the driver. So just beware of that, keep that in mind. And the main other thing that I'll touch on as it relates to this is this orifice size must be taken in concert with whatever servo you're installing for second gear. So your billet pistons, like what we have here with the Superior Tech, as well as the Sonic Superhold and other similar servos, you actually don't need as much orifice sizing as you would if this was a Corvette servo. Okay, so just bear that in mind. You have a little latitude, there's some margin for error, but you don't want to be at extremes between the difference in sizing here versus here. Okay, AFL balance and torque converter clutch regulator feed. Do not drill these holes under any circumstances unless you are installing a Transgo shift kit. And if you're installing a Transgo kit, follow their instructions to the T. So let me explain what's happening and what they're having you do. When you drill these holes, you're lowering pressure in these two circuits, okay? These two hydraulic circuits, you're lowering the pressure. Now, why would Transgo have you do that? So when Transgo gives you the kit, in that kit come a couple of different springs, okay? And in the case of the TCC regulator valve, a completely different valve. The white long spring that comes in their kit is intended to be used in concert with the original spring that comes in the actuator feed limit valve bore. So the white spring slides into the interior of the factory spring, and what that does is that spikes up pressure. It increases it fairly significantly. So what they're having you do is bleed off the excess pressure so you don't have an overpressure condition in that circuit by drilling this hole to 93 thousandths. Now, same thing with the TCC. They give you a valve and they give you a stiff blue spring to replace the valving that's currently in that TCC bore. Same deal, pressure goes way up, bleed off the excess by drilling that to 93 thousandths. Again, this is their kit. I wouldn't recommend you deviate from it, especially if you're relatively new to working on these transmissions or any transmission. But if you're going to do your own mods, like I often do, then do not drill either of these two holes, because it'll take worn out, otherwise partially impaired AFL or TCC regulator bores, and it'll make them much worse. Okay, last thing I'll touch on as it relates to the plate is the low reverse feed hole here. So it's 110 thousandths, and as you see, I've written too big in parentheses on it. For an overwhelming majority of applications, you don't need to really do anything with the low reverse feed. The 4L60Es, especially the later model units, reverse engagement's perfectly fine. There's really nothing you need to do to alter it. In the case of the 700R4s, especially the pre-auxiliary valve body 700s, reverse and forward engagement was rather abrupt. I mean, it was firm, it was stout, and it's gotten softer ever since. So now there's a couple scenarios, a couple exceptions to this general rule where it would be prudent to beef up the low reverse apply circuit. One of those is specialized heavy-duty applications, such as like a snowplow truck. So plowing snow, maybe in a vehicle like the kind of which would have a 4L60E, it would be something that would be plowing like a business parking lot or church or maybe a side street, or something like that. But either way, the vehicle is going to be in constant state of moving forward, then backing up, and then moving forward, in and out of reverse, especially under slippery conditions where there's a tendency to build up heat. So firming up the low reverse engagement is going to help mitigate that to an extent. So by drilling out the hole 100 to 110 thousandths in combination with removing the low reverse check ball out of the capsule here at the rear of the case, that will dramatically increase the firmness of engagement for low reverse. Okay, the other situation is tactical driving. So vehicles used in a military LEO agency contractor capacity, private security, personal protection detail vehicles, things of that nature. They may see a lot of a lot of scenarios where they are either aggressively pursuing suspect vehicles in the case of law enforcement, or escaping and evading threat vehicles in the case of security or personal protection. So a lot of transitioning in and out of reverse, a lot of J-turns, a lot of going around buildings and down alleyways and backing up and changing direction. So again, same deal, a lot of stress on the reverse pack, much more and above what a vehicle using a daily driver would ever see. So it would be a good idea to beef that up as far as low reverse is concerned. All right, that's the video. I appreciate you making it this far. If you're still watching, thank you so much. Be on the lookout for future videos. And as always, I appreciate all your time, your viewership, your engagement in the comments, your likes, your shares, and of course your subscriptions. If you haven't subscribed, please do so already. Thank you so much, and we'll look forward to seeing you on the next video.